All right, let's jump right in. You hear the term data science thrown around all the time, right? But what does it actually mean? It can sound really complex, maybe even a little intimidating. Well, today we're going to pull back the curtain and break it all down by following the life of information, from just a bunch of raw numbers all the way to powerful predictions.
To really get a handle on data science, we first have to appreciate how much data itself has changed. It really wasn't that long ago that data was, well, pretty simple. It was small, it was structured, it was static. Just think of those neat little spreadsheets where everything fits perfectly into rows and columns. But then, everything changed. Data got huge, messy, and it's constantly in motion now. We're talking sensor data, information from our phones, you name it. And now it's a whole new ballgame. We're not just looking at a single file anymore. We're dealing with entire systems of data that are all talking to each other, all the time.
So with this absolute explosion of information, this giant tangled ecosystem, how in the world do we even begin to make sense of it all? And that question right there is the entire reason the field of data science even exists. To figure that out, we're going to walk through the life cycle of data step by step. First, we'll face the sheer volume of it all, what we call the data deluge. Then, we'll get into the nitty-gritty of gathering good data. After that, we'll talk about finding the truth that's hidden inside it, navigate the tricky ethical questions, and finally, see how it all comes together to actually forecast the future. So yeah, our journey starts with the problem itself, the data deluge. It's pretty simple, really. The world just became flooded with so much information, and it's so complex that we needed a whole new discipline, a completely new set of skills, just to turn all of that noise into a clear signal. Okay, so where does a data scientist even start? Well, it all begins with the absolute foundation, gathering good data. Because no matter how fancy your analysis is, there is one unbreakable rule: garbage in, garbage out. The quality of what you put in determines literally everything that comes out. And one of the biggest traps you can fall into when gathering data is something called sampling bias. This is basically when the group you're studying isn't a fair representation of the bigger picture. See, for your results to be accurate, your data collection has to be random. Like if you only survey people leaving a high-end gym about their fitness habits, your results are not going to represent the whole city, right? If your starting sample is skewed, every single conclusion you make from it will be skewed too. But gathering data isn't just about getting the stats right. There's a huge ethical responsibility from the get-go. So let's think about this real-world scenario. A small business keeps all of its customer info on a computer that's not protected. The owner thinks, we're too small, nobody's going to hack us. Is that ethical? It's a tough one, but it really shines a light on how these data practices have real-world consequences, no matter how big or small you are. All right, so once we have data that we think is clean and sourced well, the real detective work begins: finding the truth. This is the analysis part, and it requires a super healthy dose of skepticism to separate what feels true from what the numbers are actually saying. A huge piece of this is understanding the difference between a story and a fact. Look, stories are incredibly powerful. It's how we make sense of the world. But a story can also be super biased or just focus on one tiny perspective. Facts are different. They're objective. They're things that can be checked and verified. A truly great data scientist has to be an expert at telling the difference between a really compelling story and the cold, hard facts. And that leads us to maybe the most famous rule in all of data analysis: correlation does not equal causation. Correlation just means two things are moving together. For instance, winter product sales might go up in the US at the same time summer product sales go up in Australia. They're correlated, sure, but one isn't causing the other. Causation is way, way harder to prove. That means one thing directly makes another thing happen, like how increased emissions cause a rise in temperature. Mixing these two up can lead you to some seriously wrong conclusions. This whole idea of responsibility is woven through every single step we've talked about, which brings us to maybe the most delicate part of the job: the ethical tightrope. You know the saying, with great power comes great responsibility? Well, with great data comes great responsibility. Ethics can't be an afterthought. It has to be at the very core of the work. Just take a look at this number: 3 billion. Just let that sink in for a second. What on earth could that possibly represent? That number, it represents people. 3 billion of them. Back in 2016, Yahoo had to reveal that data breaches had exposed the personal information of about 3 billion users. This wasn't just a technical screw-up. It was a massive ethical failure that had a very, very real human cost. And sadly, this isn't some rare event. The Marriott breach compromised the passport information of 383 million guests. We've seen social networks, without asking permission, feed users extreme content just to see how they'd react. We've even seen supermarkets use what they call security footage, not for security, but to analyze how we shop so they can make more money. The ethical minefields are absolutely everywhere. So, after all of this careful collection, all this deep analysis, and all of this ethical tightrope walking, we finally arrive at the ultimate goal: forecasting the future. This is where all that hard work really pays off. It's where the true power of data science comes to life. At its heart, forecasting is really just using the past to make a very educated guess about the future. By analyzing all of that historical data we've so carefully cleaned up and understood, we can build models that predict what's likely coming next and do it with surprising accuracy. It's really the culmination of this whole journey. So let's recap the whole blueprint, the path from a messy pile of data all the way to a prediction. Step 1, you gather good data, and you do it ethically and without bias. Step 2, you dig in and find the real signal, carefully separating what's just a correlation from what's actual causation. And finally, step 3, you use those hard-won insights to make informed predictions and, hopefully, make better decisions. So what's the big takeaway here? I think it's this. Data science isn't just about programming and algorithms and spreadsheets. It's a deeply human field. It's a discipline built on curiosity, on interpretation, and, maybe most importantly, on responsibility. And that leaves us with one final big question to think about. As our ability to use data to see what's coming gets better and better, a new question comes up. If we can predict the future, what is our responsibility to it? That's something for all of us to chew on.